Okay, so in this video, we're going to walk through an example where we are going to create an Amazon Lex bot to simulate saving a survey information. It will also utilize and save to a DynamoDB database the records, as well as show how we do this through Lambda as part of the effort. With that, let's go ahead and get started. So the first thing is kind of want to walk you through the bot we're going to create. So it's going to be a simple bot called My Survey. It's going to accept 4 pieces of information: the first name, the person's phone number, the rating, a numeric rating, as well as an account type value. And let's walk you through what this would look like. And for purposes of keeping this somewhat simple, I'm just going to use the test panel here within the Lex dashboard to demonstrate. So I would start off by saying I want to take the survey, and first thing I'm going to do is it's going to ask me for my name. I'm going to go ahead and put in Randy, and it's going to ask me for my phone number, so I'll say 123-456-7890. That's my phone number. And then on a scale of 1 to 10, I rate your service. I'll try 88 just to kind of show you that what should happen is that it should remind me that the ratings must be between 1 and 10. So there's some validation there. So I'll put an 8 in this time. So it'll let it go to the next option. And then it's going to ask me for what type of account are you registered as. So I'm going to put in blah and say I don't recognize what that account type is. And it's going to require that it's going to remind me that the 2 account types are business and personal. So that's because this account type is going to be only those 2 types will be supported. So the validation will make sure that if someone puts in something it doesn't recognize, it will make them correct it. So I'll put in business this time. Hit enter. And then I get a confirmation prompt here asking me to confirm that I want to go ahead and store it. I'll select yes. And then I'll get a confirmation message saying thanks that we have recorded your survey. So that's the end of the conversation. Once the conversation is over and it's been stored, if we go over to our DynamoDB, we refresh here. I have a single table here called surveys where I'm going to store all the information. And there's the record that I just created with a unique number, or unique ID, I should say, the business type, first name, phone number, and the rating that I've given it. And that's what we're going to demonstrate. That's what we're going to create today. So I wanted to kind of show you how that looks, and let's go ahead and show you how this is done from beginning to end. Okay, so we're starting here at the beginning. We're going to utilize AWS Academy for this. However, you can do the same thing if you have your own AWS account. But I'm going to use the Sandbox lab environment that we've been using in the course here. So go ahead and start the lab if you haven't already done so. Once you get there, you can click on the AWS link here. Green means the lab's ready to go. So I log in, get to the manager console, and if this is the first time you've been here, then you may need to go ahead and select your service. But I've got a number of services I've been using in the past, and that's why my list of services looks this way. So we're going to start off with creating the Lex bot. So let's do that first. So I'm going to go into Amazon Lex and get started. All right, I'm going to come in here and I'm going to create a new bot. First thing is that we want to use the version 1 console for the purpose of this. Just right now it's a little simpler to do that one. So right now it defaults to version 2. So just make sure you're on version 1. So let's go ahead and create. And this time we're going to pick a custom bot. And I'm going to call it My Survey. Language of choice, we'll pick English US. We will pick a voice, which we don't really need to worry about for the purpose of the demo, but it does require you to pick one. And we'll select no for the COPA requirements. And let's see what else we need here. Session time out of 5. And go ahead and create. All right. So we start off with that. First thing we have to do is create the intent to get us going. So essentially, this will kick us into. We only have one intent, which is to create a survey. So let's go ahead and create that one intent. If you have multiple different things you're doing, you can create multiple intents and do different things. So I'm going to go here and just do survey. Add. All right, and I'm going to say the first thing I'm going to do is what is going to kick us into this intent. The first thing that the bot will need to know is how do we know which intent you want to use, and we're going to use utterances to let us know which one those should be. So in this case, to kick us into this intent, the user would say something like, I want to complete the survey. Okay, and that should do it. You can add additional ones, additional messages, and as we spoke before, the Lex environment is sophisticated enough to kind of help. The user doesn't have to enter exactly what you see there, but it'll figure it out based on similar types of phrases. So for our purposes, this is enough. For right now, we're not going to pick Lambda. We'll leave all this the same. We're going to add in our data elements here. The first thing we're going to ask for is person's name. So we're going to pick from the slot types, and we're going to pick just name, slot type. These are all the predefined ones that you can get, or you can use your own, create your own, or you can use the generic one like alphanumeric. But I'm going to pick, let's see if I can find name. Okay, US first name. There we go. US first name. What is your first name? That'll be the prompt that we give the user. Let's go ahead and accept that one. We also want to ask them for the phone number. So we'll say phone is the name of the intent, and we'll come down here and pick phone. Phone number. What is your phone number? We'll just do two more here. We're going to do rating. And this will be a numeric rating. So we'll just pick Amazon number. So we'll say what is your rating? Okay, and last but not least, we will do the last one, which will be the type of account it is. So we'll say account type. And this is simply just going to be an alphanumeric string. So we're just going to pick alphanumeric string. And we'll say those. Okay, let's add that. All right, so for right now, we'll go ahead and just leave the prompt, leave the base. We won't do any fulfillment Lambda function just yet. We will add a confirmation prompt, and we'll just say, okay, do you wish to save this survey? And if we click no, survey. Okay, and then we'll just go ahead and click save intent. Let's go ahead and build it. And once it's done building, we'll go ahead and test it out. All right, once it's successful, we'll go ahead and let's test it. So I'll type in survey, please. And notice my utterance was different than what I was expecting. So again, it's smart enough to figure out what I meant by that and which intent we need to follow. So it popped me into the correct one here. So because it's asking my first name, I'm gonna go ahead and put Randy. All right. And actually, let's fix one thing. I need to make these required so that it'll actually prompt me for those. Let's go ahead and rebuild. Save and rebuild. And let's do this one more time. All right, once it's successfully rebuilt, let's go ahead and try it again. Survey, please. All right, survey. There you go. There's a phone number 12345678990. What is your rating? So I'll type in 4, and we'll type in business. There you go. Then click yes and save it all. Now at this point there isn't anything happening because we have not hooked this into a Lambda function. We've simply walked through the basics of the bot itself. Things like validation aren't done. So if I'd put an invalid business or invalid account type, I should say, or invalid rating, none of that would be captured because we have to put all of that into Lambda, which we will do next. Okay, so I've created a couple tabs here. So I've got my Lex that we just did, and I now have also opened a tab for Lambda and DynamoDB. So these are two additional things now that we'll go ahead and create. Let's go ahead and create the DynamoDB first. This is where we're going to store the records to. So I'm going to go and create a new table here, and I'm going to call it surveys. All right, and primary key, I'm just going to make it an ID as a string, leave all this the same, create this. Let that be created. Once it's done, we'll be able to then start saving records to this table. Okay, so the table is created. Obviously no items yet, so let's go ahead and leave that there. Let's jump over into Lambda. And here we're going to create a new function, and we're going to do this from scratch, and we're going to call this one the survey fulfillment. We'll just say survey function. Okay, and we will pick Python 3.8. You want to change the permissions. Remember that when you create a Lambda function, it must have access to whatever we're going to need to store to. So in this case, we're going to access a DynamoDB table. So you need to make sure you pick a role that has access to whatever table you created. Since I'm in a lab environment here, that's a little simpler. I can just select an existing role that they have for you. But if you're doing this within a normal AWS account, you would have to create the role, and then within that role, go in and add access to the Lambda table. I'm sorry, to the DynamoDB table we just created. But for our purposes, we'll just go and keep it somewhat simple. Let's go and create the function. All right, now when you first create it, this is the default you get when you're doing one from scratch. So there's nothing here. We're going to go ahead and start filling this out with the details of how we do this for a Lex application. So the first thing is we need to let's add some imports at the top that we're going to need access to. So there's a number of imports that we're going to need, including logging. So I'm going to go ahead and add what we have at the top there. So let's go ahead and go here. Extend this one. So we have a number of different imports we're going to use. Obviously, we need access to logging. We want access to Boto 3, which is the API, the Python API for AWS. And we're going to create a client record or a client variable that points at the DynamoDB API. And then we're just going to create one constant here that points at our surveys table. Okay, so we'll use that later. All right, and we also have set up logging, so we can log messages. We'll show you how you can actually monitor and see how your application's doing and also debug it. So we're going to set that up, and we're going to set the logging level to debugging so we can see details as we go through that. There's a number of different things that we need to use, and to make it somewhat simple, there's some helper functions which I will post to the Blackboard course. so you will have access to this entire file. But I'm going to post in a number of helper functions that will get us going with it. So let me go ahead and set this up real quick. All right. So these are helper functions here. I'm just going to paste those in. And these helper functions are ones that just do some things like, for example, converting a value to an integer safely. So if we can, it's going to be protected. If there's something wrong, it just returns none, which is null in other languages. So if for some reason a value that's passed in can't be converted, it simply resets it to none. This one also does some basic exception handling that we'll use to wrap some of our calls, so that we want the Lambda function to be well behaved. So if something fails, we don't want it to always abruptly kill the process or kill the execution, right? There are times where things, for example, if the string has not been set yet, we don't want that. We don't want an empty string to cause the Lambda function to fail. We want to be able to gracefully handle things that we expect. So we're going to use that for that purpose. These other ones here, elicit, swap, confirm intent, close, and delegate, what they're doing is they are setting up the appropriate JSON response. Everything, all the communication back and forth between Lex and Lambda is all done through JSON. So essentially, we're going to be reading a JSON response, a request coming in from Lex, which is passed into the function, and we're returning something back. And depending on what we're trying to do, there's different Java payloads that get sent back. So each one of these helper methods simply just make that a little easier for us as we go through this. And again, as I mentioned, I will post this entire file to Blackboard that you can use as well. All right, so we've got all of the helper functions. We also have a validation, something similar for validation, where it helps us build a validation result. So this is how we're going to use all of these things for validating the data. So this is making sure that the rating is within range, or that the account type is business or personal. And if they enter something that's unexpected, we gracefully handle that. So that's the purpose of these. Okay. All right. So we have our Lambda handler. This is the entry point for everything that comes in through Lex. So we get all the details that Lex sends us through this event parameter. We can then reach in there. This is a JSON object. This comes in here. We can reach in and do what we need to do to read the data out. All right, so the first thing we want to do with this is we want to create, we want to kind of dispatch this to do something special. So what I'm going to do here is I'm going to create another method, and this method is what's going to start us executing the request or response back. All right, so every time the Lambda handler is called, we're going to call our function, and I'm just going to replace this with a couple of things here. So we're going to set the operating environment, so we're going to assume that the user is in New York for time zone. It doesn't really matter for the purposes of our demo here, but we're going to go ahead and set the time zone and assume it's New York. Here's the logger, so this will be logged. So when someone calls this function, it's going to log out a debug message, and I'll show you later where you can actually see that within CloudWatch. All right. Then we're going to call this new method I just created called return dispatch event. So this is going to go off and send the event that came in, all the details of the event that came in, to this new function called dispatch. So just kind of creating more of a modular design here, right? To keep these methods relatively small. I could have put all this in the same method, but it's just kind of a better practice to keep your modules small-ish if you can. So that's kind of what we're trying to do here. All right. So whenever an event comes in, we're going to then go into the request and see what the intent was. So that intent is going to be the name of our Lex intent. So in our case, it's going to be called my survey. Okay, so that's what's going to come in there. So for our purposes, I'll just change this to my survey. That's the intent name that we're called it. So this has to match. So this intent name here has to match what we call it inside of Lex. So I called it my survey there. So I just got to make sure this is my survey, because you can create Lambda handlers that handle multiple different events, event intents, I should say. We're only doing one here for a survey, but if you wanted to, you can create multiple intents and have one Lambda function handle them all. Okay, so that's kind of what I'm showing you here. Is we're just going to set up right now to only expect our single my survey intent to come in, and if it gets anything else, it's going to throw an exception to let them know, hey, you're calling a Lambda function that doesn't support this. So if someone accidentally picks this Lambda function for another intent or another purpose, it'll gracefully handle that and give an exception message that will be shown in the logs as well as returned back as an error message to Lex. Okay, so if we get the right intent, then we're going to go ahead and call the logic to do the take survey. Now the take survey is what's going to do most of the heavy lifting to actually handle our specific processing. Okay, all the work we want to do for handling a certain when someone takes a survey. So what we're going to do here is we're going to go in and put a new method in here called take survey. All right, so we'll paste that in. And we'll put that right here. All right, so this is the take survey method. So this one essentially takes in the event data, and first thing it does, it goes into that object and reaches in and gets the slots object out, and then it pulls each of the different pieces of data that we've set up in our Lex here. They go into slots. So all of these things here, there's going to be a corresponding value that goes with each one. So these lines here are reaching into that array and pulling out the first name, phone number, rating, and account type values that correspond to these 4 slots. So if you had a 5th one with a new name, you just simply, if you want to, then you just create another line here and put your own new variable for that one. So we're just creating 4 variables and pulling out the slot values. So it's gonna pull out the first person's first name. It's gonna pull out the person's phone number, the rating, and account type, whatever they've entered in, and put them in variables. Okay. We're not using session attributes, but session attributes allows you to coordinate multiple different conversations so that they can pass data back and forth. For example, if you're doing a booking application where you're booking a hotel, when you're done booking the hotel, they might want a car. So you can send all that data from the hotel that overlaps the car, and they don't have to fill it out again. We're not doing that for this purpose, but it's just there because the function requires it. All right, so we have a couple logger message. Now the first thing we're going to do is look for this invocation source, and there's different types of invocation sources that we have. When you see dialog code hook as invocation source, what that's saying is that you're doing a validation. All right, so we're doing a validation step here. If this had been validated, or the validation was completed already, and you wanted to do something else like save it, that's a different invocation source. And there's, as I mentioned, there's a number of different types of invocation sources that you can use. So you're going to, if you're writing these, you're definitely going to want to look through the Amazon Lex documentation, the developer's guide, which has the details. But here you can, if you want to read up on all the different invocation sources, what they mean, here's the topic that has it. So if you get dialog code hook, that means Amazon Lex has set this value to the function, pass it to the function to validate the user's data. So we're in the validation step. This is not where we're ready to save yet or complete the conversation. Right now we're doing the various validations. So anytime the user puts data in to the conversation, it's going to go and call the Lambda function to do any kind of validations that you want. Once all the validations are done and the user is getting ready to go ahead and save it, or we're getting ready to complete the operation, we would get a different fulfillment code hook as our invocation source. All right, so that's the one that comes in when we're ready to do the save operation. All right, so if you go back and look at our example here, what I'm saying here is if we got the dialog code hook, then we got to do some validation. So that's what this is doing. This is validating all of the data. In this case, I'm only validating a few things. I'm actually only validating that the rate is in range from 1 to 10, and validating that the account type is either business or personal. All right, but we do the validation, and then if for some reason a validation is false, so if validation result comes back as if validation result is false after we validated, so validate survey is going to do the heavy lifting, which I'll talk about next. So validate survey will pass in, we're going to pass in all of our data to validate survey. It's going to come back with a true or false. All right. If for some reason it is not valid, then we're simply going to return back to the user so they're reprompted to re-enter that data. Okay. And then that's what this is doing. Delegate basically returns the control back to the LexBot to do its next thing. So this will end the execution for the Lambda function if for some reason any validation stops. We simply return back, hey, you got to fix this, and the Lex front end will handle presenting the correct message to the user. Okay, so anytime we are doing anything with dialog code hook, we do our validation. If for some reason it's not this dialog code hook, then it's the other one. It's the final one, which is this fulfillment code hook. So we're simply going to then just go ahead and save our survey. All right. So that's what the save survey does, which we'll talk about that in a second. And then once we're all done saving, we'll go ahead and close out the request. Okay. So let's take a look at the validate survey. So we're going to go ahead and add that one in next. So validate survey. Let's go ahead and put that message. That function right there. Okay, so this is the validate survey call. We simply we're passing in the slots data. We're reaching and grabbing all the data out so we can do our validations. This is where it's using those special try exception. So it's kind of making this so that it's friendly. If for some reason the values are not set to anything, it will gracefully handle that. All right, so we get all of our data the user enters. All right, so here's our validation for rating. If the rating is less than 1 or rating is greater than 10, then we return a false, and we pass back a build validation result of false rating, and we give an error message. This is the error message the user would see. All right, so we're essentially sending back some JSON that will tell the user first off which slot was failing, and then what message do you want to give the user. Okay. All right, so if we're good there, let's say if that one fails, then we're done. Again, it's going to return back, and execution is going to go back to the bot. The Lambda function is going to stop. If account type, we also validate account type next. All right, so here we're simply making sure that we have a valid account type. So let's go ahead and show what that looks like. Valid account type is really just going to make sure that the account type is either personal or business. So I have an array of 2 values, personal and business, and then if the account type that was passed in is different than personal or business, it will return false. So that's what this is valid account type function does. Passing the account type that the user entered in, check it against the ones that we know about, personal or business, and if it's false, then it's going to go ahead and return back false there. Account type is the slot we want to go back and fix, and here's the nice message you want to give them to let them know, hey, you got to fix it, and by the way, these are the 2 that are we're expecting, so they can enter in correctly. If both of these are okay, then we return true. All right, that allows the progress, that allows the rest of the function to continue on, so return true from there. Okay, so going through the take survey, so if we're going to check to see what comes back, if anything comes back as false, we go ahead and return back what was sent to us from the function. And otherwise, we go ahead and save the data. Okay, so that's the last one we got to set up, is save data. So that is where we're actually going to save the data back to the DynamoDB table. Let's go ahead and paste that in next. Okay. All right, so save survey simply takes the data, the first name, the phone, rating, and account type values, and it goes ahead and generates a unique ID. That's what this is doing. It's generating a unique ID for the table, and then it's calling the DynamoDB client put item method for the table. This again is a constant, so that table name is what we passed in up here, surveys. So we've got that, so we're setting the table name, and here is the data that we are saving for that, and it just saves it out. Okay. All right, so that is most of the function. Let's check it out and see if we broke anything. So let's go ahead and deploy this. All right, now once it's deployed, we can go back to our Amazon Lex and change it. So first thing we got to do is check that we want to use a Lambda function. Let's see here. There we go. Let's go ahead and refresh so that function shows up. There's our survey function. Now we're going to give permission for Lex to invoke our function. And we're going to come down here to fulfillment. We're going to pick the same function name. Our single function has a dual purpose. It's doing data validation as well as saving and completing the conversation, right? Fulfillment, if you will. You obviously can create different functions, one that does data validation and another one that does fulfillment. There's advantages and disadvantages of doing that, but the one advantage is it keeps it somewhat clean, but the disadvantage is that you might have to duplicate some functions, or it's a little more complex to do that if you want to share some of the functions we have between the two. We would have to work through that a little bit, but so for right now, for simplicity, I'm just going to use the same function. That's why I did it that way. All right, let's go ahead and save that, and we'll go ahead and build. Let that thing do its thing. I'll let it build there for a second. Once it's done, we'll go ahead and test it and see if we have any errors. All right, looks good. Let's check it out. So we'll try it. Survey. And we'll say it works correctly so far. So that tells me, at least if you get the first prompt here, then it tells me that at least there isn't a generic issue with the Python logic. It's working correctly. Because I didn't test it, we can definitely run it. We can definitely test this out through Lambda, but let's roll it this way and see how we do. So I'm going to type in Randy. Phone number is 123-456-7890. Rating, and I'm going to put in, let's see what happens with the validation. So this should fail. And it does. So I got that prompt that came back. Ratings must be between 1 and 10. So that looks to me that the Lambda function is getting called correctly. So I'll put a 10. And let's try the second one. Blah, SDF. And that one's also working. So it didn't recognize that type. So I'm going to go ahead and type business. All right. Yes. Let's go ahead and save it. And it says recorded. So let's go over and see if we got a record in our DynamoDB table. And there it is. So it worked correctly. So everything looked like it worked correctly. We didn't miss anything. What you can do also is, you remember we did put some debug statements in there. And if we go over here back to the Lambda, go over to the monitor, this is where you can see how your Lambda function is performing. But more importantly, this is where you get to the error logs. So if for some reason your Lambda function fails, you can click on the CloudWatch log for that. And anything that is being recorded, in our case we have some debug messages, and you can kind of see the different debug messages that are coming in from that Lambda, from the Lambda calls themselves, right? So you can kind of see here, there's our messages. The debug information is there. I'm trying to see if I have, so this is coming from my survey, bot name. This was the debug message that I had written out in there. So any kind of exceptions that happen, if for some reason it fails, you get an error message. First place you're going to go is you're going to want to go into the log groups for the function itself, and you'll see it creates this, I'm not quite sure the exact duration, but it kind of groups these together, creates these log streams, and it kind of groups, and eventually it'll create additional ones. But so in this particular log stream, it may encompass numbers of calls being made. So it's not simply just a single one. But so just kind of when you're looking at the logs, you may scroll to the bottom, always get the latest one from the bottom, and then if you run it multiple times, you may have to go back here and you'll see additional log streams. Just click the one at the very top. Once you get in here, go to the bottom of the log, and that'll be the latest error messages that were being recorded. And that's it. And if you have any questions, please reach out. Thanks.